Greetings, everybody. So here's a problem from our assignment that was sent to me, and I'd like to show you how to do it. So the question goes like this. Evaluate this definite integral by integration by parts. So to discuss this in pieces, I'd like to do this. The first thing I have to tell you is that ultimately we would use the fundamental theorem of calculus to evaluate this definite integral. What that means is that I would have to figure out somehow the antiderivative of natural log 15x. Once I find that, I can plug in essentially the bounds of integration. Okay, so that's what the fundamental theorem of calculus gives us as a tool to evaluate definite integrals like this. The hardest part is probably finding the antiderivative. I'll give you another example real quick. Here's a much easier one. The fundamental theorem of calculus as applied to the definite integral from pi over 6 to pi over 2 cosine x dx. Now, in this case, the antiderivative is really easy to find. In fact, you probably just know what it is. The antiderivative of cosine is sine because the derivative of sine is cosine. So we've got the antiderivative. From there, we plug in the upper bound of integration, get sine pi over 2. We subtract, then the lower bound, sine pi over 6. And we calculate from there to get 1/2. Now, where we are in our class is in finding this antiderivative. It might be obvious what the antiderivative is. Maybe you just know it. Maybe there's some technique that we use to find the antiderivative, such as integration by parts. Okay, so I'll use integration by parts. According to these instructions, it says use integration by parts. I'll use that to find the antiderivative. So here's how I'll do it. I've got this integral, and I aim to solve it by integration by parts. What that will look like is this. Here's our basic formula. Okay, we see the original integral as containing two functions. One's called f, the other's called g prime. We decide which function is f and which is g prime. And then as a result, we evaluate this right-hand side of the equation to completion. That's how we use integration by parts. One perhaps difficult part of this is how do you choose what is f and what's g prime? Okay, so as I look at this, I see, well, it appears there's only one function there, natural log 15x, when integration by parts requires that we see two functions. Okay, but what I'll do is I'll see, well, there are two functions. One of them is the constant 1, and the other is natural log 15x. Now I have to choose between those which one is f and which one is g prime. Okay, so there's a strategy for choosing, and I've covered it in another video. All right, I have it posted on Canvas. If you go to our homepage on Canvas, if you go to modules, if you go to videos for assignment 1, in this video at about the 10-minute mark, all right, integration by parts part 1, 10-minute mark, the strategy for how you choose is discussed. So I'll refer you to that. Now, if we apply that strategy, we will choose our functions like this. Of the two functions given in that integral, one of them is natural log 15 of x, one of them is 1. F of x will be natural log of 15 of x, or 15x, and g prime will be 1. Okay, so there I've made my choice. There's only two choices. The other choice would have been that f of x is 1 and g prime is natural log 15x. If you tried that, it won't work though. All right, so this is the one that'll work. Now, as a result of those choices, I need to find f prime. As a result of having chosen f, I find f prime. And the result of having chosen g prime, I find g. So if f of x is natural log 15x, what's f prime? What's the derivative of that? It is 1 over x. Now the catch here, you would need to know your rules for derivatives and associated techniques from Calculus 1. If that's the point that you're getting stuck, then we can discuss just that. Okay? Now, next thing, if g prime is 1, what's g? G would be the antiderivative of 1. G would be whatever you take the derivative of to get 1, and that's x. Okay, so I choose f and g prime, and then based on those choices I solve for f prime and g. And that is everything we need to know to complete the integration by parts formula. Now, if I use these in that formula, I'll get this, which is x natural log 15x minus 1 over x times x, but that's just 1. So this turns out to be just 1 times dx. Now, at this stage, I would have to evaluate this integral somehow. Maybe it would be easy, maybe it would still be difficult. This time it's easy. What is the antiderivative, the indefinite integral of 1 dx? It's x. So there it is. I have my constant of integration. That's the antiderivative. That's the thing I need ultimately to evaluate this indefinite integral. Okay, sorry, definite integral. All right, now let's do the evaluation part. So what does the fundamental theorem of calculus say that we do? So we take our antiderivative, plugging in the upper and lower bounds of integration. Okay, so first I put in e, and it would look like that. I would subtract, and then I would substitute 1, and it would look like that. Okay. Whenever we're dealing with logarithms, there may be some other rules that come into play for our calculation. So, for example, one rule for logarithms, one of many rules, is that the logarithm of one thing times another, the logarithm of a product. So log base b of m times n is log base b of m plus log base b of n. So I could say for logarithms, multiplication in here amounts to addition out there. So natural log 15e, 15 times e, is natural log 15 plus natural log of e, but natural log of e is 1. So this is e times natural log 15 plus 1. Distribute the coefficient e there across that. I'll get e natural log 15 plus e, then I'll get minus e. Distribute this subtraction across that, negative natural log 15 plus 1. Combine like terms and factor, and I get it. Okay, so at that point we're done. Now that, what you see right there, our final answer, that is what is here as the ultimate final answer on my math lab. But what about this first part? It says use integration by parts so that the integral is simpler and choose the correct answer. Well, which of these, I mean, I know I didn't work it exactly how it appears here. Here I see the bounds of integration are within each of these choices, but you know, if basically this is what we get from integration by parts. If I had decided to keep writing the bounds of integration, it would have been for this part 1 to e, and then for this other integral 1 to e. So look at that and you'll see what? You'll see this. So that's why D is indicated there to be the correct choice. Okay. All right, now so that's what I have to say about this problem. Where you would take it from here is, if you understand the integration by parts technique, okay, that's good. That's one objective. The other are little things like, if f is natural log 15, how do you find what f prime is? Okay, so that's a calculus 1 topic, which I don't mind reviewing, but I won't make the focus of videos like this one. So there's a lot of little things like that as you go along that you might not be so good at from calculus 1, or maybe you forgot for whatever reason. There may be other things along the way that you need to see more of. If that's the case, just let me know and I'm happy to help.